Hello guys, welcome to this new video. In the last video, we talk about the cost function. So cost function क्या था? Cost function क्या था? Cost function जो था वो था j of theta 0 and theta 1 equals to the mean square error था cost, so 1 by 2m summation over I equals to 1 to m h theta of xi minus yi, okay, and it's so square. It was a cost function. So since this was a cost function, mean square error, this was the mean square error, okay, this was the mean square error, and the nature of the cost function was it was convex function, okay. So what is the profit of having the convex function? It has only one minimum, like this is the cost function, okay, and this is the minimum, this is the optimum, okay, optimum. So in this video we gonna minimize the cost j, this is the cost, using the gradient descent algorithm. Gradient descent algorithm. Okay, we're gonna use the gradient descent algorithm. So it's very interesting. We're gonna use the gradient descent algorithm all over our machine learning course, maybe. So what is the gradient descent algorithm and what is the use? So first we'll have some little outline of gradient descent algorithm so we can understand it properly. So what we do, we first start with any random value. Okay, start with some value of theta 0 and theta 1, so it can be random, okay, and next what, we just keep changing it, keep changing theta 0 and theta 1 to what, to reduce the cost of theta 0 and theta 1 until we end up at minima, okay. So for this we start from there, okay, sorry, we start from here, then again we go down, 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 so we go down until we reach here, okay. This is how we gonna use it, the gradient descent algorithm, the gradient descent algorithm. So as I said, the cost function is like this, okay, the cost function is convex. So suppose if the cost function, we say this is the cost function, and if it's not convex, it's like this, okay, this like this. So we can see this is the optimal point, this is the optimal point, but it's global, okay. This is the actual optimal point, global optimal point, but there are few, these are the local optima, these are the local, this is also local. So if we use the gradient descent algorithm over this cost function, so we may end up in any local optima like this, we can end up in here, here, or here, or here. There are few chances we can end up also here, but there are few chance of it, ठीक है, कभी कभार हो सकता है, probability बहुत कम है. So mainly हम सब local optima में मतलब इधर ही हो सकते हैं. So this is the problem of using the gradient descent algorithm on a non-convex function, okay. So what is the gradient function and how are we going to use it, the mathematical form? So we'll see this over here, okay. Okay, so if we write the gradient descent algorithm like this, suppose the gradient descent algorithm is what, the gradient descent algo, if we write the mathematical of it, so what will be it, it will be the repeat until converges, okay. We'll repeat the gradient descent algorithm until the converges, okay, if under the algorithm. So what we do, we have the parameters. Actually the main thing is the parameters, okay. In the hypothesis, if you have like this, h theta equals to h theta of x equals to theta 0 plus theta 1x, so the model, it is depending on these parameters. If we change these parameters, the model will change, okay. So we have to change these parameters to get the accurate model. सो इन द ग्रेडियंट सिंपली, अगर आसान भाषा में बताएं, ग्रेडियंट डिसेंट एल्गोरिथम में हम थीटा 0 एंड थीटा 1 वैल्यू जो है उसको हम एकदम एक्यूरेट लाएंगे, ताकि एक्स के ऊपर अप्लाई करने के बाद एकदम हमको परफेक्ट प्रेडिक्शन मिले, ठीक है, ये हम करने वाले, ठीक है. वी जस्ट सिंपली चेंज दिस थीटा 0 एंड थीटा 1 सो दैट वी कैन गेट मोर एक्यूरेट रिजल्ट, ओके. बस यही करना है, बस, और कुछ नहीं. So जब हम प्रोग्राम करेंगे तब देखेंगे ये बहुत ही इजी है, बहुत इजी है. ओके. So in the gradient experiment what we do, we repeat until convergence. The theta of j, we assigned it to theta of j, sorry, equals to theta of j minus alpha into partial derivative with respect to theta j of theta 0 and theta 1. Okay, and in the here case j equals to what? For j equals to 0 and 1, since it's a single variable, we're gonna use it for 0 and 1. Okay, we gonna, okay, so we're gonna do this. So first you can have the question, what is this, what is the alpha, what is this? This alpha is called the learning rate. Okay, learning rate. This is the learning rate. We have to choose it properly. Suppose they mostly we use the method to choose the learning rate. Like first, if we choose 0.5, okay, sorry, 0.1, or we choose 0.001, or we can choose 1, or we can choose 10. It depend. Okay, we can choose like this. This is the better way to select the learning rate. We can choose or anything, we can choose 0.5, 0.002, or whatever we can choose, but this is a perfect way to choosing the learning rate. This is a better way, actually the most used way to use choose the learning rate. Okay, so what is the use of learning rate? हमने बताया था कि suppose this is the function, this is the cost function, and depending on the learning rate it will go like this. It's accurate, बहुत अच्छा हुआ तो धीरे धीरे ऐसे 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 होता जाएगा and will end up in the मिनिमम. ओके, एंड अगर लर्निंग रेट ज्यादा होगा तो सपोज बहुत ज्यादा लर्निंग रेट डाल दिए, 15 डाल दिए, 50, 100 डाल दिए, एंड ये बहुत कम है. सो व्हाट विल डू, इट विल जस्ट सिंपली go like this, then go like this, then go like, it will just simply miss the optimal point. Okay, so this can happen. Okay, so to maintain this we are going to select the learning rate properly. हमको learning rate बहुत अच्छे से select करना है. So this is the way to select the learning rate. And the next thing is the partial derivative of the cost function with respect to theta j. How we gonna do this? We gonna perform this mathematical form over here. So we gonna do this for theta j. Okay, we gonna do this. Oh, sorry, j of theta 0 and theta 1. So we gonna do this for both theta 0 and theta 1. And next what? We gonna assign the value in the gradient descent algorithm. First we gonna calculate this, then we're gonna assign this value over here. Okay, so if we do this, suppose first we gonna do this for what? For theta 0. Okay, we gonna do this for theta 0. Okay, sorry. So if we do this for theta 0, what will be the, so partial derivative of j of 0 and 1 for theta 0. So if we write this, so partial derivative of what we know, 1 by 2m summation over I equals to 1 to m. We're not going to use the h theta x. We're gonna simply write this like this: theta 0 plus theta 1 x minus y. This is also I whole square. We're gonna use it because we have two partial derivative with respect to theta 0, so we have to simplify this in this way. Okay, so now we're gonna do it. So this is a constant, this will come first, 1 by 2m will come first, and then we'll have the partial derivative of theta 0 and summation over I equals to 1 to m, and theta 0 plus theta 1 x of I y of I. I think you guys know what is partial derivative is. If you don't know, you must learn it because it's very important. So then again 1 by 2m. So in the partiality form with respect to theta 0, so क्या होता है इसमें, हम जस्ट थीटा 0 के रेस्पेक्ट में भी करते हैं और बाकी सब 0 पकड़ लेते हैं. ठीक है, सो इन द डेरिवेटिव फॉर्म तो क्या होगा, 2 होगा जो सामने आ जाएगा, एंड इट्स अ कांस्टेंट, वी विल ऐड इट ओवर हियर, देन वी विल ऐड समेशन ऑफ i इक्वल्स टू 1 to m ओवर हियर, एंड ये अगर 2 हो जाएगा फिर -1 हो जाएगा तो ये 1 ही पड़ा रहता है. सो इट विल स्टे लाइक दिस, थीटा 0 प्लस थीटा 1 xi माइनस yi. ओके, लाइक दिस, एंड विद रेस्पेक्ट टू दिस इसको अगर हम फिर से डेरिवेटिव करें तो ये 1 हो जाएगा एंड ये टोटल 0 हो जाएगा. So into 1. So we can like it like this. इसको ऐसे ही छोड़ सकते हैं for this, or we can write into 1 for this. Okay. So ये होता है क्या? ये होता है partial derivative of j theta 0 and theta 1 with respect to what? With respect to theta 0. Okay. This is what. Next we're gonna do, we're gonna find the with respect to theta 1 partial derivative of j of theta 0 and theta 1 with respect to theta 1. So what will it be? So partial derivative of theta 1 with respect to theta 1, sorry, and this is the same 1 by 2m summation over I equals to 1 to m, and this is theta 0 plus theta 1 xi minus yi. This is simple as that, is the same thing we're gonna perform. Okay, तो क्या है 1 by 2 हम डायरेक्ट पार्शियल डेरिवेटिव कर देते हैं, ये जो स्क्वायर है ये सामने आ जाएगा into 2 and then it will be I equals to 1 to m and it will remain the same theta 0 plus theta 1 xi minus yi. So since we are performing the derivative using the partial derivative theta 1, so theta 1 का रिस्पेक्ट में जो रहेगा ये सिर्फ रहेगा, बाकी सब जीरो हो जाएगा. So this will be 0 and this will be 0, only the theta 1 derivative and the remaining will be x to the power I. So this is the partial derivative with respect to theta 1 of j of theta 0 comma theta 1. Okay, so हमको मिल गया है, ठीक है. तो हम ये यूज करेंगे, दिस वी गोना यूज दिस, सॉरी वी गोना यूज दिस एंड दिस. ओके, हम देखेंगे जब ग्रेडिएशन में अप्लाई कैसे करेंगे. सो हमको पार्शियल डेरिवेटिव मिल गया. सो इफ यू गो बैक टू अ फंक्शन ओवर हियर, सो वी कैन सी क्या हमको पार्शियल डेरिवेटिव इसका वैल्यू भी मिल गया एंड वी विल कीप, वी विल चेंज इट ओवर in the program. We will do this. Now we are going to simply write this in a simplest form. Okay, so if we say, then what is the gradient descent? So if you write gradient descent algorithm, so what it would be? So for we have to write it for both theta 0 and theta 1. Okay, हम दोनों के लिए अलग अलग लिखेंगे, एक साथ नहीं लिखेंगे. So for theta 0 we will assign theta 0 to theta 0 minus alpha into what? It was a partial derivative of the first function. So we'll do what?
Sorry, I am not sure.
Sorry, my Alexa start working. So we'll do what? We'll do, we're gonna use this, simply we just copy paste this. Okay, so I'm gonna write this alpha into here 2 close, remaining is 1 by m, and here also the 2 gone. So we have 1 by m. Okay, 1 by m summation over I equals to 1 to m theta 0 plus theta 1 x I minus y. Okay, yi, and also you're gonna do this for theta 1, and what are we gonna do? Theta 1 minus alpha into 1 by m summation over I equals to 1 to m theta 0 plus theta 1 xi minus yi, and we got it. There was also in multiply with xi. Okay, we had it over here. Okay, so this is the gradient descent algorithm we derived. So that's all for linear regression. यही करना होता है, ठीक है. मतलब if we summarize all the things, let me copy this. So this will be better. If I copy this, बस हमको क्या करना होता है, तो if we summarize all the linear regression over here, so it's very simple. First we declare the model. Okay, first हमने मॉडल सिलेक्ट किया, मॉडल सॉरी फर्स्ट मॉडल बनाया हमने. Okay, so what was this was h theta of x and theta 0 plus theta 1 x, and for each sample, of course, for each sample I equals to 0, y equals to 1 2 dot up to n. Okay, ये था हमारा मॉडल डिक्लेरेशन. देन व्हाट वी डू, we declare the cost function. Okay, and the cost function was mean square error, right? And it was 1 by 2m summation over I equals to 1 to m h theta x I minus yi whole square. This was the cost function, and now then we use what? The gradient descent algorithm. We just simply use, we can, if we just let me minimize it, use the gradient descent algorithm over here. दिस वॉज द थर्ड पॉइंट. बस जब प्रोग्राम करेंगे हम बस ठीक यही करेंगे, ठीक है. हम एक डेटा सेट लेंगे एक्स और वाई का, फिर हम मॉडल डेवलप करेंगे, जिस मॉडल को लिखेंगे पाइथन में, फिर एरर फंक्शन को लिखेंगे, फिर ग्रेडिएशन लिखेंगे, बस खत्म, लिनियर रिग्रेशन प्रेडिक्ट हो जाएगा. सो इट विल बी वेरी मच सिंपल व्हेन आई डू द प्रोग्राम इन पाइथन. बहुत इजीली समझ में आ जाएगा. देन अगेन अगर तुम ये वीडियो देखोगे तो और इजीली समझ में आ जाएगा, ठीक है. सो यू कैन डू दिस फॉर, दिस इज ऑल सिंगल वेरिएबल एंड फॉर मल्टी वेरिएबल देयर इज नो डिफरेंस. बस हम एक सिंगल वेरिएबल ले रहे हैं, उधर से मल्टी वेरिएबल लेंगे, ठीक है. बस ऑल विल बी द सेम, वेरी सिंपल एज दैट. ओके, सो यू कैन डू दिस इन द नेक्स्ट वीडियो. ओके, तब तक लिए बाय. I hope you like this video. So Okay, see you later. Bye.